All right, so I guess we'll get started then. Good afternoon, everyone. Welcome to our Pro D workshop. Today, we'll be talking about artificial intelligence for educators. So really quickly, right off the bat, first of all, we would just like to quick land acknowledgement. So UBC Gearing Up is located on the traditional, ancestral, and unceded territories of Musqueam, Tsleil-Waututh, and Squamish Indigenous peoples. So a little bit about ourselves. Who are we? We are in Gearing Up Engineering Outreach, and Gearing Up is dedicated to basically trying to spread and promote STEM-related topics, science, technology, engineering, and math to everyone, essentially children and youth of British Columbia, also teachers and teacher candidates such as yourself. So for kids, we have fun hands-on projects that take place in events and clubs. But for teachers and professional development, we host workshops such as this. And we also do have a team that is dedicated to outreach that travels around different parts of BC, delivering the content that I have just described. So a little bit more about specifically professional development. So our sort of mission statement goes like this. We want to increase diversity in STEM fields and encourage people to at least try different STEM topics. We want to prepare youth for the future better, as STEM is a very volatile kind of field. We want to continuously get students interested and think about new technologies and science innovations. And we also just want to help students discover that they can do STEM, because there's often the stigma that science, tech, engineering, math is a very nerdy kind of subject, and they need good math or very narrow-minded kind of calculative mindset. We want to show them that that's not the case. It's simply not true. And we want everyone to think that they can find their place in STEM, should that be interest to them. So a little bit about ourselves. Today, I am Alex and joined by Reed. So since I'm in front of the camera already, I'll start with myself. My name is Alex Guo, and I use he, him pronouns. I didn't go to UBC actually, but I went to BCIT and I graduated with a diploma in information technology. I'll switch it to Reed. Do you want to come here and do it in front of the camera?
Sure. Come in front of the camera so people online can say hello. Hi, everybody. My name is Reed. I go by he, him, and I am a graduate from UBC here, where I studied cognitive systems. I did the psychology stream of that, but I also did a lot of computer science and philosophy. And that was a degree all about intelligence, both in natural systems like humans and animals or plants, as well as in artificial systems like computers. And that is what we are here to talk to you about today. So first, I just want to go over machine learning and artificial intelligence and a little bit about what it is. So we can kind of think of these as all belonging to various aspects of computer science, where at the most basic level, we just have algorithms. And algorithms are really any set of instructions which can be repeatedly performed to complete a task. So you can think of a set of instructions like a recipe for baking a cake, or instructions for how to tie your shoes. Those could both be considered algorithms. But we often think of it in terms of code and instructions which we give to a computer, which then the computer can execute in order to solve a problem. Now, artificial intelligence is a subset of algorithms. So artificial intelligence is made using algorithms. And we can think of artificial intelligence, or AI as it's commonly known as computers which can autonomously solve tasks at human levels of competence. And does anybody out there want to tell me, what does the word autonomously mean?
By itself.
Yeah, exactly. It's by itself. It doesn't need a human supervising it. It doesn't need a human controlling it every step of the way. It can do it by itself. And then we have machine learning. And machine learning is a subset of artificial intelligence. And that is a specific type of AI in which the computer can actually learn how to perform a task without having to be told every single step by a human. So we can think of artificial intelligence as just any computer which can perform a task without the human necessarily having to go over every step. That doesn't necessarily imply that the computer learned how to do it by itself. Especially in the 20th century, a lot of approaches of artificial intelligence just had us giving huge lists of instructions to the computer in order to try to account for every possible case that might arise. And that works, but it gets inflexible, and it's not always great for things like language processing. Or we can see in a second things like recognizing images. So one of these approaches to creating AI, which I just talked about, is giving a set of explicit instructions, right? You know, you're at point A and you want to get to point B, or you want the computer to accomplish point B, and you'll give it that little arrow there. You'll say, okay, I will tell you how to get from A to B. I'm going to give you a full list of instructions on how to get there. I'm going to tell you every step of the way. And this works well for a lot of problems, but eventually we're going to run into a problem that's a little bit too complicated for us to just give a simple set of instructions. So here I have the question, I have an image and I want to know, is this image a cat or a dog? So I want to ask you, the room, as well as Zoom here, what are maybe some rules that I could come up with that could tell me if this is an image of a cat or a dog, something that I could tell to a computer? What are some ways that I could tell if an image is of a cat or of a dog? Yeah?
The ears.
The ears? What about the ears?
The ears of a cat are more distinct. They're different.
They're different how? How would we quantify that? How would we say that?
Triangles.
The little triangle, yeah, you're saying like they're a little pointy?
Yeah.
Yeah, okay. We can have some like pointy ears like that, maybe. What else?
I think like the ears could be like there's like huskies and stuff, but like I can't think of a dog with like a nose of a cat, like small, tiny.
Small nose. Okay, so maybe something about the shape of the nose. Okay. What are some other ideas? Do we have any online here? Any? You can type it in the chat, or you can also just unmute yourself and chat. Love to hear it. Let's get one or two more ideas. What do we think? Yeah. The shape of the eyes. Yeah, definitely. You might be able to do something with the shape of the eyes. Dogs are usually bigger. Yeah. Yeah, definitely. Sometimes it can be hard to tell in an image though, right? If something is bigger or smaller, you kind of need context for that. I've also heard people say like things like, oh, you know, you can tell that it's a dog because its tail will wag. We might not be able to tell that in an image. Green eyes, cat is small, dog could be large, definitely. Yeah, green, yeah, maybe colored eyes might be one. The problem with a lot of these is that every time we come up with an example, we can usually find an exception to that example. So I think we heard one about pointy ears and the husky, right? You might have a husky with pointy ears. Examples that I've gotten before are like maybe a tongue hanging out, you know that it's a dog, but cats can do that too. Maybe you don't get a nice angle of its face either. Maybe you only see it from the side or from behind, or you only have like a little bit of it. Human looking at that can still tell that it's a cat or a dog. So there must be a way of doing it, but coming up with like a set of instructions that's going to work for every possible picture, it's really, really difficult. And we realized this early on when we were trying to develop computers, which could identify what is in an image. We found it really difficult for it to do this. And then we started creating a different approach. We started using machine learning where we wouldn't program the computer with the rules. Instead, we did something a little bit different. We said, okay, we're not going to tell you how to get from point A to point B. I'm just going to give you a bunch of examples. I'm going to say, okay, this image here, this is a cat. It's almost like a flashcard. You can think of it where you give it a bunch of examples of what the image is, and then you have like the answer on the back, and then the machine will go and it'll try to answer those questions. So you might give like a bunch of images of a cat, all with the label cat. And you'll give it a bunch of images of a dog, and you'll give them all with the label of a dog. So again, it's like flashcards, and it's a little bit like how a human would learn or how a child would learn, right? As a child is learning, it won't know things that it hasn't been seen before. If you try to tell it like what a dog is and you point to something and you say, that's a dog, right? It might not be able to tell what a cat is afterwards. Unless you've gone and given it another example of a cat, it might point to a cat and say, dog, you know, that's a dog. It looks similar to that thing that you showed me earlier. And you say, no, that's a cat, right? And we do the same kind of correcting process with a machine. So the process that we take here is we take in some kind of data, And then you give it some kind of test. You give it some kind of like flashcards like test. And then repeat this process until you slowly get more and more examples and it gets better and better at this test. And at the end, you produce something that's called a model. And this is some kind of representation of the problem. So this is going to somehow encode or represent your problem. And you're going to be able to use that to figure it out. Now, this model is usually something called a neural network. Has anybody heard of the words neural network before? Yeah, can I get some show of hands if you have heard of neural networks before? A little bit. Yeah. You also might have heard terms like artificial neural networks or deep learning. We're not going to go into tons of detail about this today, but I think it's important to know that this is the dominant approach to AI right now. And when you hear these words, you can just think of something that uses data, a bunch of examples. It gives a test on that data somehow, and then you repeat that enough times until it gets better and eventually produces a model. Does anybody have any questions so far? I just want to pause for a second before I dive a little bit more into the details of how this works. Apparently it's not recording, but didn't we go through this?
I think so too.
Okay, 1 second. Yeah, it says it's recording. Mine says it is.
It's not giving me the weird. Carry on.
Okay. No, I appreciate you stopping us though, because if it is not recording, mine says that it is currently recording the call. I
Knocked it out.
Great. Sounds fantastic. So keep going. Good. And yeah, Sophie says it's recording. Fantastic. Yeah, any questions on how this process works so far? Ready to dive into some more of the details, learn a little bit more? Okay. So let's go through an example of how a neural network might actually learn something. So let's say that I pose a problem to you, a budding computer scientist. You want to create something that can solve a problem through machine learning. And my problem for you is I have a whole bunch of berries. You know, I have a whole bunch of berries that are either going to be blueberries in blue there or strawberries in red. And I also have a scale, so I can tell what the weight of each of these berries is going to be. Now, this problem is probably simple enough that you can look at it and know what the answer is, right? You can say, okay, what weight does it need to be considered a strawberry versus what weight does it need to be to consider a blueberry? This problem is simple enough that a human can look at it and understand what the answer should be. But a lot of the time, when we have machine learning, just think back to our images, you won't be able to look at it and know exactly what that point would be. So how would a computer go and find out these things by itself? And actually, I want to pose this to the audience. How could you take this? How could you take like a number line like this? You could take some kind of data that you know what the answer is and use that to figure out where this threshold should be between your two answers. What could you do? Yeah.
Would you break it down into like a smaller portion, the test out 4.1, 4.2 round?
Yes. Yeah. So what would that testing involve?
So you'd have to have some type of input.
Yeah.
Of like how much weight it would be.
Mm-hmm.
So for example, like 4.1, and if it's still, you would see it, the output would be blueberry or strawberry.
Mm-hmm.
And then I guess that's how the network learns or like.
Yeah. So you got half of the process. Okay. So you got up to the point where you have some kind of input that might be your weight, right? And then it'll give you some kind of output, right? What happens if that output is correct?
And it learns that, oh, this is whatever the output is.
Yeah. Yeah. So if the output is correct, do you need to change anything?
No.
Do you need to touch anything? No, it works. You got the correct output. Great. Everything's fine. What if you get the wrong output?
And then you test again.
You test again? Yeah.
Yeah.
Okay, you're getting much closer. Yes. So the way that we can do this, I wanted to see how close we could get without me giving too many. we can take in the weight. And then we can almost think of this, this little input here as being something that we have on a dial, right? Where we have to say, well, how much do I want to listen to this input, right? And you can think of this dial as moving this arrow left and right across your number line. Okay? So if you get, for example, a blueberry, right? You have something that has an input of 4 grams and it has the answer. You already know in advance, like this is a blueberry, and I'm gonna give it a blueberry. And it answers, this is a strawberry, right? What you can do is you can actually just turn your dial a little bit. And you can say, okay, I want to move my threshold just a little bit over so that I would consider that to be a blueberry instead. And you can do the same thing on the other side. You can say, okay, if I have something here and it gives me the answer, I get 6 grams, and it gives me the answer of a blueberry when it should be a strawberry, I can just turn my dial down a little. And this is how machine learning works across all scales. This would be like what we call like a one dimension, because it's just going along a single number line. But machine learning, a lot of these problems won't just have one dimension, they might have thousands or millions of them. And what you can think of this as doing, if you want a more like intuitive example of what's going on, is imagine that you're trying to find the top of a hill, except you're blindfolded and you can't see in front of you. What you can do is you can take a step and figure out, did I go up or did I go down? And if you went up, then you can take another step and you can take another step. And you basically can keep following this path, what we call this gradient, up your hill until you get to the very top. And where every step you take, you instead go down. So you can think of like the kind of the vertical dimension here as the number of correct answers. So every time you get a wrong answer, right, you can take a step and you can say, okay, I'm going to try to change something. And I'm going to go to a new area. I'm going to change something. And I'm going to see if I can get more answers or better answers the next time. So the overall process here is we take in some kind of data. You give it a test on that data. So you can think of like the flashcards again. Then you'll give it a score. How many of those did you get right? Did you get it right or get wrong? You can look through each of the ones you got wrong and make a small adjustment. And we can do some calculus and we know which direction we need to change this number in. We know how we can adjust our network so that it's a little bit better. And then you repeat this process and you repeat this process again and again and again until you eventually get a much better answer. And this is how machine learning works. Now that was a little bit of a heavy content. So I just want to pause again and ask, how are we doing on the understanding of that? I want like thumbs up to thumbs down. How do you feel about your understanding of this so far? You're doing good? Okay. I'd also love to know how Zoom participants are doing. If maybe you just want to give me like a quick number from like 1 to 5 in the chat. And I just want to see if there are any issues and if there's anything that you want me to go back to and explain again, or if you'd like to move on to the next thing.
I was one of the Zoom people. I'm just,
Oh, perfect.
I was walking, so I missed a little bit of the end.
Yeah. 4 to 5. Okay, I will take that.
I've been in the room the whole time and I'm at 3.
Okay. Yvonne, did you have any questions?
So I'm good.
Okay.
I'm
Okay.
trying to fully engage.
Okay. Sounds good. So what I would love to do next is if everybody can open up their laptops or find a friend with a laptop, we're actually going to be doing a fun little activity here where we're going to be training our own neural network a little bit to recognize some images. So what we should end up with is something that looks a lot like this. And what we are going to do is we're actually going to leave this program alone for now. We're going to come back to this a little bit later. Thank you, Sophie, for the link. You're going to go up to the top of your screen here, and there's going to be a button that says Teachable Machine. And you're going to click on that one. And it's going to bring you to a different website that I'm also going to make bigger. That looks like this. So this is a project by Google, and it's just an online resource that you can use to train your own machine learning projects. And it's really straightforward and simple and a lot of fun. So has everybody been able to make it to this webpage? Yes, good, fantastic. If at any point you get lost, just let me know, and I am happy to come back to explain anything. So you're going to click on an image project, and then you want a standard image model. I'm going to turn this around quickly so I can see what I'm doing over here as well. So what we have here is we have a little machine learning network where we are going to be providing it a bunch of examples, a bunch of example images of different categories. So you can think of this as very similar to how we had the categories of cat and dog, and we gave different images to each one, and then it learned which one. Today, we are going to be doing something very similar here. So what we are going to do is today we're actually going to be doing some fun object recognition. So I see that in front of most people, we have various recycling objects in front of us. And we are going to create a small recycling sorter for ourselves today, where we're going to be able to hold up something to our webcam, and it's going to tell us what garbage or like what bin it should go into. Especially, you know, this might be really useful at UBC for newcomers. We have a whole bunch of different bins of garbage and recycling, and we want to make sure that people are putting things in the right spaces. So what you can do, and if you don't have recycling in front of you, you can also do this with any object. So if you want, you can use like a water bottle or a phone or something like that. But you're going to have at least, we're going to say at least two. So I want to cut this a little bit shorter today because we have a special discussion at the end that I want to give lots of time for. And so you're going to have two different classes of objects. So I'm actually going to get, I have a little kombucha bottle here. Bottle that I got earlier. So I'm going to use that as one of my objects that I want it to recognize. So I might type in my category as something like bottle. And then I'm going to go and I'm going to click on webcam. And you can see that there was an error in opening my webcam.
It's open on Zoom right now.
Because it is open on Zoom. Yes, so I'm going to have to, you should not have to do this step too much. And turn off my video on Zoom. And reload the page. I'm just going to get rid of that as an event. So if you want, you could follow along with this and choose your own item. This can be something like a pencil. It can be a set of keys. But if you do this in the classroom, it can be really fun to do it with the recycled objects in your classroom. There we go. There's our webcam. Okay. So what I'm going to do is I'm going to hold up my object. And I am going to switch this to record. So what you saw, what I just did is there's a little setting button on the bottom, if you'd like. And this will change it between something that records for a number of seconds versus something that you have to hold down to record. The recording for a number of seconds is really good if you're doing like poses or things like that with your body. I just switched it over to this one. And I want to give it a bunch of different images of my bottle here. And I want to give it from a bunch of different angles so it can recognize it from a bunch of different angles. And it's fun. Do this. And then I'm going to use my phone as my other object here. But if you have something like pieces of paper, that can be really fun. Yeah, we have some yogurt. Actually, yeah. Yeah, I'll use an unopened yogurt. That might be fun. I like that. So I have a little yogurt container here, and I'm going to use that as my second object. There we go. So I can go to my webcam as well again. And for some reason, it keeps defaulting back to the other one, which is not what I want. Then I'm going to hold to record again. Give it from a bunch of different angles, See if it can recognize this object. And you want about, I mean, this one I have a little bit less, anywhere between like 50 to 150 images tends to be a good amount for this. And when you have your samples collected, when you have the images, you can just go and click this train model, which might take a few minutes to do, depending on how fast your computer is. And I'm also just going to wander around and check how are we feeling about these things.
I'll also be acting as tech support.
Yeah, so that's nice. So you go and you use them. You end up running into the problem where you accidentally include images that you didn't want. You can go and hover over them and delete them, or you can click on the top right corner and say remove all samples. I'm also going to give us some nice background music. How are people doing on this? We have our trained model. So what you can do is when you have it trained, you should be able to see your thing here, and you can hold up the object in front of your camera, and hopefully it should be able to recognize which is which. And if you notice that there's like a perspective or something where it's not able to recognize your object very well, you might want to go back and redo it and add some more examples. So here I noticed that it's not very good at recognizing it's a yogurt container when I have like my hand a little farther away. So I might want to just go and add a few more. Okay.
Can you show again how you tested it?
Yes, so after I hit this training and after this finishes, it's just going to do this a bunch of times. You can see is it has my little webcam show up. And what I can do is I can just hold up the object and you can see down at the bottom, it has, that's actually how confident is it right now that it is seeing that image. Okay, so this one is doing pretty well right now. But I have an interesting question. What image is it recognizing right now?
Oh, that's you were in the way.
I'm in the way, right? Now, right now, what does my machine learning network think it is seeing? A yogurt container. Is it seeing a yogurt container? No, it is seeing a picture of my face. Why does it say yogurt container though? Why does it think that I am a yogurt container? Yeah.
Because you're definitely not a bottle.
Apparently I'm definitely not a bottle. Yeah.
Did your face appear in more of the yogurt container images than it did bottle container images?
I guess it must have. Yes. It's clearly it somehow thinks that I am. What happens if it still thinks it's a yogurt container? Can I get it to go back to bottle if I do something strange? No.
Mine thinks the blank screen is a yogurt cup versus a plastic spoon. When I'm not showing anything.
Yeah. So this is an interesting thing with machine learning networks is I like to think of them as like a really tiny child, you know, like, oops, something that like a child that has never seen anything in the world ever before, right? It has never opened its eyes. And the only thing in the world that it knows are the images that you've shown it. And right now, it only knows of two objects that exist in this world, either a bottle or a yogurt container. And it will try to fit everything that it ever sees into one of those two categories. So we really have to be careful how we're training these networks, and make sure that we give it the option to recognize more things, or that we train it with more things. So what I might want to do is I might want to actually add in a third class here that just says none. And this is like my catch-all for like everything else that is not a bottle. So I might have like pictures of myself. I might have like pictures of my hand. I might have like nothing at all. And now if I train it, again, what we should see is that it is able to recognize me this.
So would it be better if you put your face on this video?
I think I do have it on some of them.
Okay.
Oops. Yeah, I've had my face and my hand in there a bunch. Yeah, but that's a good question. Is yeah, you definitely do want to make sure that you give it all possible examples. Okay, so here we have none. Great. I go back to my bottle. Fantastic. I go to my air container. Fantastic. So this is working pretty well. How is everybody else's networks doing? Have we noticed anything strange happen? Any bugs that we have run across that we maybe haven't anticipated? Okay, is everybody ready to move on to the next step? We're all feeling pretty confident in our network. We think that it's pretty good.
One of them is okay, the other one's not.
I mean, ultimately that
It
it doesn't need to be perfect right now. We're just doing an example. But interestingly, what happens when I change my background? You can also try this out. What happens if you change the direction? Because I trained this and I trained all of my none examples with like a kind of this dark background in the corner, and the ceiling is part of my image. If I rotate this so that now it's looking at the door, it again thinks that it's a yogurt container. I'm going to plug back in the computer. And this is actually one thing that in examples like ours, it can almost be a little bit funny or comical when it makes these mistakes. But these AI systems, these machine learning systems, are being used for lots of things across our society. A really big problem in AI right now is bias, where things like facial recognition systems work much better on lighter faces than they do on darker faces. Companies like Amazon have gotten in trouble because their resume scanning systems prefer male names over female names, because Amazon has hired more male sounding names in the past. So whenever we're creating these systems, we really have to think about what data we're giving it and make sure that that data is representative of all possible cases, all possible use cases that we might have it for. So when we have our model done here, we can go to this top right corner where we're going to see a button that says it's blue and it says export model. And we're going to click on that. And then we're going to click on the button that says upload my model. Now, as a note, if you decide to do this in your classroom, there aren't data privacy concerns here. You are not uploading the training data images when you do this. The images that you use to train it are not being stored on any Google servers. It is just all of those, like all of the weights, all those little dials, which I talked about earlier. It's the positions of all of those dials which are being stored. The data that you use to train it is not included in this, just so that you know you can use this in a classroom. Has everybody been able to export their model and update or upload their model to the cloud? All doing good there? Okay. Okay. Our next step is you should get this link here. It's like this shareable link. And we are going to copy that link to our computer. Then we're going to go back to our PRG AI blocks here. So this is just like a test version of Scratch, if you're curious. It is by MIT, the same people that made Scratch. And if you know anybody at MIT that works on this, please tell them to just make this version included in the regular Scratch version, so we don't have to go to this other website. But what you want to do is in the bottom left-hand corner, there we go. You should see this blue button that has some blocks with a plus symbol on it. You're going to click on that. And then you're going to click on this very top one here, top left, that says Teachable Machine. And this just gives us some additional blocks. Oh, I did something wrong because I forgot a very important step. And this is a step that you do have to do. So before you do what I just did, you're going to go back to this, your image model here, and you're going to turn your input to off. This turns off your webcam so that it no longer is using it. Because what you just saw when I went over to this one and tried doing it is that it couldn't find my webcam. Nope. As long as you have that link, it should stay the same. However, if you do retrain your model, you'll need to update your cloud. Yeah. Then, so in PRG blocks, you'll go and you'll select the block extensions, bottom left-hand corner, and select Teachable Machine as one of them. And what you should see when you do this is that your image should appear in the background of your Scratch little canvas here. Everybody doing okay on that so far? Fantastic. Okay. So our next step is that we are going to go into the events box. That's not the events box. Into the yellow events box and grab the one that says when green flag is clicked. When we're done that, we can go to these new blocks that we just made. And you're going to click the top one that says paste URL here. And you're going to paste that URL that you copied from the previous website. So you can paste something by either doing a Control or Command V. It's the shortcut. And when you're done that, you want to hit this green flag button up here. And what you should see is you should see this green check mark appear next to these Teachable Machine blocks and kind of in the top left corner. And I'm going to go around now and I'm going to check that everybody is able to get to that green. Oh, okay. So you're on the main Scratch.
Oh, okay. I think you already got it.
Testing the Scratch. So you can go.
Oh, yeah, because
I'll just give you the link quickly. So this is a little bit annoying that it's a different version of Scratch.
category of
I'll get you the here we go.
start.
Teachable Scratch.
Second. Oh, yeah, Jesus. The bottom left teachable machines have underlined block. No, not really. Mention the. Now it's got a breach block. So that just runs the model and trained in that other case into the
Scratch is
Oh,
a
the-
fantastic.
yeah.
that indicates that it's a discussion.
No, not at all. Okay. We're not actually going to go deep into this today. Usually, I'll go to teacher and system.
Yeah, that's perfect.
So for anybody who's curious, Scratch is a really wonderful block-based coding program that is my first programming that I ever did was in Scratch, close to a decade ago now, and it's fantastic. It is really a fantastic way to learn it. It basically gives you a little canvas to play on, and then you have a bunch of blocks where you can like move things around, you can change how they look. You can have different like user interaction, like mouse presses and button presses. You can have like loops and things like that. And it is just a really fun program to play around with. Now, normally in this activity, I'd actually go deeper into how to interface Scratch together with Teachable Machine. But I want to leave lots of time for a discussion at the end of today. So I'm actually shortening this activity quite a bit. So what our last step here that we're going to do is we're actually going to go into looks. And you can say, use this say block. And you'll notice with these blocks, if you've never used Scratch before, you kind of connect the blocks together, almost like you would stack Lego on top of each other, but kind of going downward. And this is like code that you execute like one block at a time. And it's really great for kids that maybe don't know how to type yet, or they aren't that great at programming. Like it'd be a lot of effort for them to go and like try a typed coding language, which has a lot of special symbols and a bunch of stuff that can get really confusing. This just simplifies all of that, and it just gets to the instruction, and it's just drag and drop. And it's a really great way to teach like computational thinking and coding concepts in your classroom.
And in multiple languages as well. We can talk about multiple languages.
Oh, that's also wonderful. Yes. If you're curious about this, we can show you some lesson plans. I know Yvonne here is also fantastic at Scratch. There's tons of resources out there for it. I highly recommend. But today, I'm just going to kind of show you just the very basics of how you connect these two programs together. So once you have this save block, and you can find the save block in the purple looks menu, you can go back down to your teachable machine, and you can just drag and drop this model prediction. And now every time you hit this green flag and run your program, it's going to tell you what is on your screen. Yeah, and why does it think this is a box?
The background.
It's the background, isn't it?
Mine's a plastic spoon.
So what I have to do is I have to go back to my background that I trained it with here. To be able to hit right. Yeah, see there, now it's the air container. Oh no. Yes, if you'd like, you can also use a forever loop. So that's in the control tab here. You'll see that if you scroll down a little bit, is this one the forever one, Alex? I can't see it from here. Okay. And you can drag it so that it goes around. There we go. And bottle.
Because now your students more the
Yep.
Yeah.
So we actually have two different versions of this activity. One is very similar to this, where you get it to use the recycling. And then the other one we have, which is lots of fun, is you actually train it on different poses, and then you make like different emojis pop up on the screen. The reason I didn't do that one today is it takes quite a bit longer for us to go through. And yeah, we have a surprise topic at the end of today, which I really want to talk about. But I want to give everybody just a couple of minutes to play around with this one a little bit and just have some fun. We're going to do this just for 5 minutes here and play around. If you want, you can experiment with other parts of the code too. You can use things like if statements. You can say, like I've done in the past, right? If I had like a garbage item, I would make this little character have a frowny face. And if it was a recyclable item, he would have a little happy face. So that can be fun. You can drag around where your little person is. You can change what your little person looks like if you want. You can go in and add different things. This is a really flexible program. And again, I wish I had a little more time today, and I would spend more time teaching you how to do it. But I want to get out there. Yes. Yours is not working. Okay, let's see what I can do now. Yes, so right now yours is only going to run and you click that. But if you go to control, and it's going to give a forever loop. So this repeats a piece of code for forever loop. Yeah, so close. What we have to do is you have to put the forever loop around. Yeah, so if you drag it, yeah, there you go, just like that. And now if you click that green flag again, should. There you go, yeah. You're welcome. Yeah,
Like forever around both of these, but you only
Yes.
have bottom. And I was curious about why.
I'm sorry, I think I noticed sequence once.
They only.
If I wanted to, yeah.
so the use model blocks, you only actually have to do that once. Well, actually, once you get that check mark, you don't need that.
So-
So technically right now,
Here, if you
I
guys
can
do
do
this,
because I've already loaded in the model, and until
this is running loaded. So this is,
it's gonna stay slow.
Everything teachable.
this is only run when
Now,
five different ways. So the execution takes a different path when it sees this, so there's nothing indicating, remember, telling it to say stuff until you tell it to see text one will then ignores the other stuff and not executes what's in there when it sees the code. And vice versa for this one. At the beginning, it detects a spoon and it stops everything and it doesn't execute. You'll have to click there and flag again to sort of go back because your say prediction is under that loop there. Does that make sense?
That is.
So.
It basically like that's
that
like kind of
here it
details
is.
about how JavaScript the code
You
is
can do
how it
instead
interacts
is
with your browser instead of how Chrome the browser.
This,
Just
I mean, every time it's
JavaScript
a
tab
thing.
front versus tab.
you can use net else for all of these, so. So this,
Your found at that time.
now you can say if.
Using this one, sleep it because it's using a lot of processing power.
That's not the wall speed. So want that to execute beginning. If prediction is a spoon.
It tries its best, yeah. Not always perfect. How's everybody doing on this?
You want it to stop,
Maybe have to do
Okay.
something with the background, like when I
So
put back
then-
the,
then that's.
Nice in the background, keep it,
Yeah,
like-
two of these,
Well, I think you need to run.
oh, maybe. I don't know.
if-
Did you do anything? You had your background in
You
the
can do
camera.
that. You can
before
have
did the link, I think.
another
And then-
and else under it. So if we were actually thinking about execution time on that, but this would be not very good, but this is all right, so.
Yes, you never uploaded
this.
Yeah, oh, I see, yes, you have just like a
Oh,
test, so yeah, that's what you can do.
Sorry, I'm not sure what one it is on the Mac, but we'll just wind it.
If you wish. You
It's hard.
hopefully you can
Put it in, and
the
the prediction
you have
is
to refresh the page and read
the cup, and you can tell it what to do here. So I noticed you try to get it to like spin and stuff, so you can, yeah. So you can do that, and then if nothing, you can tell it to stop or do something or say nothing. Like it's all nothing, so it's really up to you, so. It's not like I'm still with every else is filled with something. So you can play around good with that, but it's not. Just try around it or do this. Yes. Obviously, we're going to use.
It should be not working and let's change the folder. But it's not working. Page edits to.
Excuse me. I want to say what it's at.
And I edited something for better, not for me. And ask
So we're really trying to use the whole project here.
Yeah, so the actual mail out that doesn't change.
yes.
I think
Yeah, sorry, I set it up in a like really messy way, so.
X or Y when you set it so that. Should I say this? Yeah, so.
Wanted to.
Refresh the page.
It's not necessarily.
You can save it for.
I'd say that metaphor so that you know where it's coming from.
Bulk for one person.
It would work for both.
Start again, we just update.
Because you're loading it from the same. That makes sense.
Okay, yeah, and you can use different things to compare with like different accounts and different models.
Yeah, but as you can see, you can also, if you go back,
Mhm,
you can also go to the teacher machine function.
mhm.
And you can also like.
So you want to stop.
Model predictions, like set how the bear says.
But I guess because I have it done. Okay. They're in the same format.
Yeah, so it's constantly looking
And you can
for, because the only option is it has,
whenever it's want to do.
if it sees.
And see if it works, and sometimes it doesn't, sometimes it doesn't. Okay.
Right.
Okay. You'll be working.
So I'm
Fantastic.
testing, and that's
Yeah.
really a lot of what coding is, so if I click start and. This is.
Okay, so
About that.
Are we working okay or so?
We're just like testing some stuff, but did you want to move on?
I do because I want to leave lots of time for a discussion today. Because if anybody has been on the internet lately, I think, especially in the education world, you might have heard of something called Chat GPT. And I have some hands up. Who has heard of this? Has anybody not heard of this? Just one or two? Okay.
I
So
was just talking this morning to a grade 10 social studies teacher who's actually taking up ethics and AI and using this as a model with his grade 11 philosophy class. I think it's really interesting.
it is, I think, one of the most interesting things to come out lately. And it is really going to impact how education works. So ChatGPT is a chat generator. You can think of it like a chat bot, where you give it a question or a prompt, and it will give you an answer back. Now, things like this have existed for a while, but this one is a little bit new because one, it's free and easily accessible, and two, it's very good. It has been very good at outputting good text. You can see like some of the examples thing here are, so you can say like, explain quantum computing in simple terms. And actually what I can do is I'm going to quickly check. And I want to see if I can go to. Now, earlier today, it can write lesson plans for you. Oh, good. It's gonna let me on. Actually, no, this is a fun prompt. What would somebody like a lesson plan on? What's a topic we would like a lesson plan for? Topic and a grade. Yep.
Volleyball.
Volleyball. Okay.
10.
Okay. So, right.
How to play volleyball for grade 10?
Great question.
Yeah.
That grade? See. Where's like the history of volleyball for grade 10 students?
Introduction to volleyball.
Right.
Introduction.
An introductory lesson plan for playing volleyball
In a grade
for a group of
Grade 10.
grade 10.
PE student.
Yeah, let's say physical education
Yeah.
students.
Just so you know,
It's ridiculous.
conversation. We're going, a conversation sort of at a lot of level in our faculty too, around the impact of AI on grading around, but more importantly, on our assignment practices and assessment practices.
Yes.
Because
Sorry, is it true that 1895 is when it was invented?
That is a good question. You should probably fact check that.
yeah, and
It-
is that Wikipedia or what source? That's one of the issues.
Yeah, so after I'm just gonna go through a quick explanation on how all this technology works a little bit, and then I'm hoping we have a solid like 30 minutes for discussions on what this means for education. I really think that this changes things quite a bit, actually. So you can see that I asked it, write an introductory lesson plan for playing volleyball for a group of grade 10 physical education students. And within about, 30 seconds, it created an entire lesson plan for me here. And at least just like as a cursory glance through this, it looks pretty decent, actually. You could use this as a template for a lesson plan, and it would probably go okay. And this has been weird because we haven't been able to do this before. This is something that is very new technology. This really only came out in the last year, and it was like private and public betas for the last year. And it's really only been in the last month that this became something that, just really hit the mainstream. Yeah.
So you can just, sorry, what did you type exactly for that?
For that entire thing.
That's just,
We just asked a simple question. Write me an introductory lesson plan for grade 10 students about volleyball.
That's what I did. And you saw, I didn't pre-prep this. right? Like this happened in real time and it wrote an entire, you know, like, what's that? Probably like a 300 word, I don't know, maybe a little bit less, lesson plan, you know, like that. You know, if you're doing this, like you could probably use this lesson plan. So that's really helpful for teachers, but you also can see maybe it can be used for some other uses, and then we'll get into that. So how does this actually work first? Because I think that understanding how it works really helps you understand the limitations as well as the potential uses and the impacts it can have on education. So one thing that's been used in natural language processing for a while, and natural language processing is the field of computer science, which is involved with computers understanding and producing human-like speech. And what we can do is you can think of words as relating to each other, almost like each word is like a distance from other words. And the larger the distance, the less related the word is to one another. So the closer they are together, kind of like the more similar the sentence or the more similar the words are. And you can actually compute like the distance between words and get a score of like how similar are these things together. So as an example here, we have something like Obama speaks to the media in Illinois. And another sentence might be the president greets the press in Chicago. And what you could do is you could take some of the key words in these sentences and you could see that they're actually all quite close to one another, and you might be able to score these sentences as being quite similar to one another. And you can do this numerically. This is, of course, a really oversimplified example, and there's quite a lot of math and analysis that can go into it, but that's the overall idea, is that you can kind of score words based on how similar. And there's something called large language models. This is what GPT is. And a large language model is basically something that uses a massive training data set. So you think of like all the cats and the dogs images that we were doing earlier. What you can do instead is you can have something read as an example, like the entirety of the internet. So that's what GPT-3, which is the base model for ChatGPT. ChatGPT is built off of GPT-3. And the GPT training set was the entirety of the internet, everything from 2021 and before. And this includes all of Wikipedia and all of the scanned books that we have on the internet as well. I do think that they went through and they tried to filter out like not safe for work things, and they did choose somewhat, but you can pretty much think of it as everything that has ever been written publicly on the internet was used in this. And before, we were talking about the number of dials which are in something. GPT-2, which was about 5 years ago, had 1.5 billion of these dials. And we used to call each of these dials like neurons. They kind of perform similarly-ish to how a neuron works in your brain. Humans have about 85 billion neurons in our brain. GPT-3, which is what ChatGPT is based off of, has 150 billion neurons in it. And they're making GPT-4, which I think is going to have over 200 million. It's crazy. So these things have gotten really large really quickly. And from a cognitive science perspective, it's actually incredibly disappointing that the solution to solving these problems is just throw more data and more compute power at it, because it means that they're not really accessible to anyone other than very large corporations, because it means that they have to train them on huge data sets and use like, I think they use something like $20 million of electricity alone in order to train this data set. It's absolutely insane. So the way that this works is it takes in two inputs. It takes in the input text that you give it, and it also looks at the previous words that it generates. And then it goes through that machine learning process, and it uses something called attention, which is just a way of saying which words in my input should I care about. And it scores those on a metric from like 0 to 1, like 0, I don't care about this word at all. 1, this word is like the most important it could be. And then it kind of puts those together and it says, okay, what is the most likely next word? So really, ChatGPT is a statistical word generator. It takes in its previous output, the words that it previously said, and your input, and then it kind of squishes those together, and it does like a whole bunch of calculus and a whole bunch of math, squishes them together, a bunch of like matrix algebra, and then it outputs a list of words with also little percentages basically attached to them. And then it chooses the one that it thinks is most likely to be the next word. And it'll continue this until the most likely word is the end of the output. And so you can really think of this as these language models, they don't really understand what they're saying. You know, you can debate the word understanding, but they're mostly just producing a statistical output. They're very, very good and very, very large statistical machines. And it's very interesting that this approach can actually output human-like text. So ChatGPT is built on top of GPT-3. Now, I did not generate this myself because I did this earlier today, and ChatGPT was actually down. You couldn't access it because there were too many people trying to access it right now. But basically how it works is like, yeah, it uses a neural network, and it uses a huge amount of text data, and it generates human-like responses. And it's quite good at things like conversational text and chatbots. And I also, you see, I circled this little thing here because there's an additional thing that ChatGPT uses, which is really neat. And it uses human feedback to say how good or how bad it is. Whenever you output a response, you can give it a little thumbs up or a thumbs down, and a little prompt comes up and it says, what should the output have been? What would you have liked this output to be? And then it uses that to calculate better answers in the future. You know, earlier I just showed you, like, you can calculate the distance between two words and two sentences. You can also figure out how to get from one sentence to another. You can figure out how to shorten that distance. So every time somebody uses it and gives it feedback, it's getting better for next time. So what are some of the uses? Really, people have started paying attention to this thing, as I'm sure you've heard yourself. The time that different sites have taken to reach 1 million users in months. Netflix took 41 months to reach 1 million users. Twitter, I think it was at 24, Facebook was 10, Instagram was 2.5, and ChatGPT was 5 days. So this is now out in the universe, for better or for worse. And I think that has some implications for education. What are some of the things that I have seen it used for? Well, we just saw generating lesson plans, very useful. I've heard of people generate diets, which includes meal plans and ingredients lists for them, which I genuinely might use for my shopping. Honestly, that sounds like it might be really useful. Another thing, people using it, you can record the audio from a meeting, put it in use another AI to translate those spoken words into written words, and then create a meeting summary from that transcript, and, including things like, make me a meeting summary with action items and who they are assigned to. That's very useful. Things like financial reports, things like scientific discovery and summarization. If you've ever had to do a literature review, it can be really annoying to go and read like 100 different papers to see what's going on in this field. It'd be really nice if you could just ask a chatbot, summarize this field of research for me and tell me what the overall average results are. I don't quite know if ChatGPT could do that yet, but it's getting close.
It's limited on the number of references that it can include.
Okay.
Okay.
I'm personally, you might know more about that specific than I do.
It's just vague.
Yeah. I think that for brainstorming, I've started using ChatGPT for brainstorming a lot. I used it to help me brainstorm parts of this presentation. I have started using it to help me write scripts for presentations. I have started using it to help me write code. I never take the output as it is exactly and do it verbatim, because I think that it does require editing. But getting past that like blank page slate where you're like, okay, I just need like, how do I start this lesson plan? Like, I just need something to start working off of. Great, here's a template. I can go and edit it. It is fantastic for that. And as you may have heard, it is also very good for writing essays and articles. And this is interesting because it writes at about the same level as your average grade 12 student who's okay with getting a B- on their essay. that's not like, it's not going to win any awards for writing. But that's, you know, about as good as the average human is at writing skills. And I think that has a lot of implications for education. So now I want to open this up for discussion. And I'd love if we got into little breakout groups in online. And I think we can probably just have a single circle discussion, or maybe let's do 2 groups of 3. That could be fun here. And we're going to chat for 10 minutes and then share after. How will ChatGPT affect education? How is this going to influence your classrooms and things like writing assignments in your classrooms?
It is a kind of a concern in that direction.
I just have one interlude slide here, and then I'll go into our next discussion. So right now, a lot of educational institutions are going with the approach of banning ChatGPT. They're just like, nope, not touching it. Students aren't allowed to use it at all. I think that's an okay approach in the short term, especially as we just really have no idea really what to do with this thing. But I started thinking about this on a little bit of a spectrum, where kind of on our y-axis here, we have a spectrum between banning it completely and using it all the time, total open access, free for all. And on our x-axis here, we have on the left, like keep assignments totally the same, make no changes to the assignments. And on the right-hand side here is edit the assignments and adapt to this somehow. And I expect that as time goes on, we're going to move up this line here. We're going to start using these things more and more, but that's going to involve editing our assignments. And I think the job of educators is figure out how to move along this axis. Because I think trying to keep things banned, it's going to be a game of whack-a-mole forever. You know, you're going to ban this one technology and it's going to come out on a new website, or somebody else is going to come out with something, or students are going to like use data on their phones to access the website or something like that. I think it's going to be very difficult to keep a ban on this technology. And I started thinking of it, I was using the example of a little bit like word processors, where once we had things that could correct for basic grammar and spelling, our expectations changed. And so we started expecting better writing, and kind of the floor of the writing quality had to move up, where now we had basic expectations that were higher. I think a similar thing is going to happen now. Another example would be something like the use of calculators, where if you give something in the form, like a question in the form that is very easy for a calculator to solve, you should expect that students are going to try to use a calculator to solve that problem. Like if you just have like here's the equation, plug in the variables and find the final answer, that's something that a calculator can solve really easy. So I think that's going to be about the approach that we need to take with things like writing assignments, where you're not going to be able to propose a really specific question, like write a 1,000-word essay on this theme, you know, the theme of love from Romeo and Juliet. It's probably going to be able to write that. So you might have to get a little more creative with the essay questions, or, you know, change it to project-based learning. I'm not entirely sure. I do have one anecdote, which I love, which is about how technology changes and people grumble about technology changing, which is there was once a very wise man who was complaining about how technology, his students, the technology has changed and his students were starting to use this technology. And he felt like they were becoming a lot dumber. They weren't able to remember stuff as well. And they weren't able to really think for themselves, and they weren't able to memorize these really long songs and poems anymore. And this man was Socrates. And the only reason that we know that he said these words is because his students took the time to write them down. And we've been seeing similar versions of this argument forever, that as technology changes, we feel like it's changing us, and we feel like it's changing our brains. And as the skills that we find valuable changes, there can be some resistance to this. A lot of the time, this concern has proved, I don't want to say moot in the long term, but this also feels almost different. I wonder if it's a boy who cried wolf scenario, where we've had so much technological change for a long time and people have been complaining about new generations, you know, relying on it too much for so long that we also may have got complacent. So I think there's two sides to this. And I'm going to move on to our next discussion question, which we're going to kind of spend the last 5 minutes on, which is just how can you use this in your classroom, with the little sub note that technically the current license that you have to agree to when you don't read your terms and service requires you to be over 18 years old. So I just have like a few just like really quick wrap up slides here. If people really have to go, I know we have gone like now 10 minutes over time. If you have to go. So one thing I just want to say is like, what is AI bad at? This is from a book by Kevin Roos called Future Proof, and I really like it. If you're curious as like, what are the important skills in the future that machines are bad at replicating? And there are 3 things that he talks about that almost by definition, neural networks just can't really do. One is anything that's surprising. So anything that has a lot of variation and is difficult to predict. So even things like emergency services, right? There's a lot of surprising, unpredictable scenarios that can happen. It's going to be a very, very long time before we have any kind of computer that is even remotely good at predicting and responding to those situations as good as a human. The other thing is social, right? There's a huge set of social, emotional skills that you have to learn. How do I work with other people? How do I deal with emotions? Or how do I work in a group? These are things that we like it when there are other humans. And even if we think that like some that we're talking to online is real, and if they fool us, as soon as we learn that was a machine, we suddenly like the experience a lot less. There's something really intrinsic about there being a conscious human on the other side of a conversation or an interaction that other humans just deeply enjoy. So that's not going to get replaced for a long time. And finally, the other thing is scarcity. If there just isn't much training data on something, like, with things like writing, again, like the Romeo and Juliet example, there's so many essays on themes in Romeo and Juliet. But if you pick like a really obscure text, or, you talk like, maybe you have like a First Nation elder come in and give you an oral history of something to do with them, ChatGPT might not know about that at all, right? So anything that is scarce, is new, or has like very little resources available for it, that is something that AI is also bad at. I just want to say that we also have additional lesson plans. If you liked what we did today and you want to learn more about it, I encourage you to go to pro-d.gearingup.ca. And we can, I think Yvonne might already have this link, but we can make sure that you get this, or you can quickly write it down. And on that resource hub, we have a bunch of free lesson plans. These are ones that I made some, Emily's made some. I think Alex, you might have a couple of them now. See, you got one in here somewhere. And you can find a bunch of different lesson plans on different topics. We really want to make sure that teachers like yourselves have access to good quality STEM resources, and we know how difficult it is to make lesson plans and how much time that can take. So if you want to do that, you can go like, here's one I made on generative art, and it uses Scratch, and it's a really fun way of learning about coding through creating art. And here we have basically like a whole lesson plan for you, the materials, instructions.
Modify it. For your context.
You absolutely can. We love it when you use this. We love it when you adopt it. We really just want more content like this in classrooms. Like, we're a nonprofit based out of here at UBC. Our entire goal is just to make sure that teachers like you have good content. So you can also if you are in teaching, and this might be, especially if you're teaching teacher candidates, and I think you have to do like a whole practicum and come up with stuff yourself, feel free to reach out to us with an email, anything like that. We'd love to come and help you, especially for new teachers. We know how hard it can be. We'd love to help out. If you have like a topic idea and you're like, oh, I want to do this, but I want to integrate the ADST curriculum at all, like I want to talk about AI, send us an email. We can set up a Zoom chat with you or something like that. Yeah,
Students who had access to the 3D printers, for example, wanted to shadow for some ways they might use that. And then they actually did a sort of a one-on-one on how to make it work, like I set it up. So it was great.
We also can do Pro-D workshops at your school. That might not be as relevant for you right now, but in the future, we can always come to your school directly, as long as you think you get 10 teachers. That say they're going to come, we can go and do that for you. We also do classroom workshops. Again, this might not be as relevant for you right now, but if you ever do get into teaching and it becomes like, like March or something like that, and you're like, wow, I just really need somebody in my classroom that isn't me, because my students they will not tolerate any more of me speaking to them right now at the end of the year. We can come and send some university students your way and run some fun activities. And then finally, we just have a feedback form. I'll just leave this up on your way out then. Thank you so much for coming today. We really love being here. If you have feedback for us at all, good or bad, we're always interested in hearing how we can improve. So thank you very much.